Hello viewers, this is Teacher Nixon. I want to welcome you to my YouTube channel. Remember to subscribe and share. In our today's lesson, we are going to learn something on vectors. And the lesson objectives is that at the end of this clip, you as a learner should be able to express column vectors in 3 dimensions in terms of unit vectors. Number 2, you should be able to calculate the magnitude of vectors in 3 dimensions. Let's start by first of all knowing what is a vector, and we define vector as a quantity with magnitude and direction. Quantity with both magnitude and direction. And remember, in 2 dimensions, vectors are expressed in terms of I and J alone. And in 2 dimensions, we only have 2 axes, that is the x-axis and the y-axis. Now in 3 dimensions, we are going to introduce the third axis, that is the z-axis, such that now we have the y-axis, the x-axis and the z-axis. I want to draw the 3 axes here on the board so that they can help us express other vectors that not necessarily move 1 unit along each given axis. How can we express, or how do we write such vectors in terms of unit vectors I, J and K? I, J and K represent unit vectors in 3 dimensions, where K represent unit displacement along the z-axis, J represent displacement, that is 1 unit along y-axis, and the first one, I, represent displacement along x-axis. I'm going to draw the 3 axes here so that they can help us express the unit vectors. So we take this one as z-axis, this one will be our x-axis, then this one will be our y-axis. So suppose we have a displacement along x-axis that is 1 unit. Yeah, let's say maybe up to that particular point we have 1 unit. So displacement along x-axis from the origin, that is 1 unit from the origin, is represented by vector I. Then we have displacement along y-axis, that is 1 unit from the origin. We abbreviate it using a vector J, and we have displacement along z-axis, 1 unit from the origin. We abbreviate it using vector K, vector K. Now let's give these given points some names. Let's call this point A, let's call this one point B, and let's call this one point C. Now first of all, we can write the coordinates of A, the coordinates of B, and the coordinates of C. The coordinates of A, the coordinate of B, and the coordinate of C. Now from the origin to A, we have seen it is 1 unit, 1. Then from the origin to B, here it's still 1, and the other one is 1. And we have said that unit is represented, that's unit vector from the origin to each particular point here is represented by I, J, and K in the 3 dimensions respectively. So the coordinate of A here will be 1, representing displacement along x-axis from 0, that is from the origin. Then displacement along y-axis of this given point will be 0, and displacement along z-axis of this given point will still be 0. So we have now the coordinate of A being 1, 0, 0. Let's move to point B. Point B still has displacement along x-axis as 0, so we'll have 0. Then displacement along y-axis is 1, then displacement along z-axis is 0, so the coordinate of that B will be 0, 1, 0. Then we have point C. Displacement along x-axis of point C is 0. Displacement along y-axis still is 0. but displacement along now z-axis is 1. So the coordinate of point C is equals to 0, 0, 1, 0, 0, 1. So we have now gotten the three coordinates of point A, B, and C. Now, I want us to write these given coordinates, or let me just say this, I want us now to have vectors OA, vectors OB, and vectors OC, which we refer to as position vectors because their reference is the origin. I want us now to write these given vectors in terms, these position vectors in terms of column vectors, So I'm going to get vector OA, that is the position vector. So this one in terms of displacement, in terms of column vector, it is going to be 1, 0, 0. Then we also have vector OB. Vector OB is going to be given as 0, 1, 0. Then finally we have vector OC. Vector OC, which gives us 0, 0, 1. 0, 0, 1. 0, 0, 1. But remember, vector OA is represented by unit vector I. So this one is the same as saying now that OA equals unit vector I, which now will be equals to 1, 0, 0. Then we have vector OB, which is now represented by unit vector J, because it's just one unit displacement from the origin. So this one is the same as vector J, which now will be equals to 0, 1, 0. Then finally we have vector OC, which is represented by vector K, which now will be equals to 0, 0, 1, 0, 0, 1, 0, 0, 1. So what does that tell us? That a unit vector in 3 dimensions will be represented by I, which is 1, 0, 0, then J along x-axis, y-axis, 0, 1, 0, then vector K along z-axis, which is 0, 0, 1, 0, 0, 1. So generally, if you have been given a vector, that is expressed in column form, for example, let's say vector OE, something like that. It can be any vector, but it has a general column vector. Let's say x, y, z. This one can be expressed in terms of the unit vectors. It can be expressed in terms of the unit vector. Please remember that x here is the displacement along x-axis, y is the displacement along y-axis, then z is the displacement along z-axis. So how can we express this vector generally in terms of unit vectors? So we can factor out this by writing it this way. So vector OE can be given by x into bracket let's write it this way. We can express vector OE in terms of unit vectors by writing it this way, because we have seen x is the displacement along x-axis, y displacement along z-axis, not z-axis but y-axis, then z is the displacement along z-axis. So how do we express this vector OE in terms of unit vectors? So this one can also be written as x 0, 0, that is displacement along x-axis. Now plus, plus 0, y 0, that is plus displacement along y-axis, then plus 0, 0, z, that is displacement along z-axis. Then we can factor out these values, that is x, y, and z, so that we have x. Here we'll have, now when we factor out x, we'll have 1, then 0, 0, like that. Plus, we factor out y, so that we have y, 0, 1, 0. Then we have z, we factor it out, so plus z to bracket 0, 0, 1, 0, 0, 1. But remember what we have just said. We have said 1, 0, 0 represent unit vector I, then 0, 1, 0 represent vector, that is unit vector j, then 0, 0, 1 represent unit vector k. So wherever now we have this, we can replace with or substitute with I, j, then k. So what does this mean? It means, therefore, vector OE now will be equals to xi plus y j, then plus zk plus zk plus zk plus zk. So generally, given any vector in terms of column vector, for example x, y, z, if you want to express that vector in terms of unit vectors, you just need to write it as xi plus yj plus zk. Maybe for us to understand better, let's have an example. Suppose you are given a simple question like this, and you are asked to express a given vector in terms of I, J, and K. A question like this, express, this one is an example. You are told to express vector, maybe let's say OB, which is equal to, let's say 3, we have negative 4, and maybe let's say 5, something like that, in terms of I, J, and K. How do we solve this kind of a question? Express vector OB, which is equals to 3, negative 4, 5 in terms of unit vectors I, J, and K. So for us to solve this question, we just need to do it this way. So note that OB, which is a position vector, will now be equals to 3, negative 4, then 5. Please note that 3 represents displacement along x-axis, negative 4 represents displacement along y-axis. Now towards a left, because it is negative, then we have 5 as displacement along a z-axis, displacement along z-axis. So this one can also be written as now displacement along x-axis, which will be represented by 3, 0, 0, then plus displacement along y-axis, which is negative 4, 0, then plus displacement along z-axis, which is 0, 0, then 5. Now we can factor out what is common here. So we have 3, which is a scalar, then we have 1, 0, 0, then now plus or minus, so it can be, you now have, when you factor out negative, this one is going to be negative, because positive times negative gives us a negative. So we have negative 4 into bracket, negative 4 into bracket, or we can write it this way to avoid confusion, plus negative 4, like that. So we have 0, 1, 0, so that when you remove the bracket, we'll get that, plus 5, now 0, 0, 1. Now remember, this can also be written as 3 into bracket 1, 0, 0. Then we have now positive times negative, we have negative 4 into brackets 0, 1, 0, then plus 5 to bracket 0, 0, 1, 0, 0, 1. But we know what? But we know I equals to 1, 0, 0. We know J, vector J as 0, 1, 0. And we know vector K as 0, 0, 1. So wherever now we have this, we substitute them back in our equation. So therefore, our OB will now be given by 3I minus 4J, then plus 5K, plus 5K. So that's how we express vectors given in column form in terms of unit vectors I. Now I want us to look at how we can find magnitude of a vector in 3 dimensions. Magnitude of a vector in 3 dimensions. To understand this, I'm going to draw a cube here on the board. So I'll have a cube like this. Not a cube, let's take it a cuboid. Let's draw a cuboid. A cuboid will be better. A cuboid like that. So we have a cuboid, we can label it. Let's take this one as our origin, O. We have A, B, C, D, E. Then let's call this one F, and let's call this one G. Now, if we extrapolate this, it's going to give us the x-axis. And if we extrapolate this is going to give us the y-axis. If we extrapolate OG, is going to give us the z-axis. Now let's take displacement along maybe x-axis. Let's say that point A, that is displacement along x-axis, point A. Let's just take it, for example, to be 3. Then displacement along y-axis on this given x-axis will now be 0. Then also along z-axis will be 0, as we have seen. We can also take coordinates of point C here as, let's say, the displacement from this particular point to that one is 4. So displacement along x-axis at point C, it will be 0. So that now we have the coordinate here as 4, that is 4 units from the origin. Then we have a 0, that is 0 displacement from the or along z-axis. Let's then take this given height here, that is displacement along z-axis to be 5, from the origin. So the coordinate here will be 0, that is 0 displacement along x-axis, 0 displacement along y-axis, then 5 displacement from the origin along z-axis. So we have this now coordinate 3, 0, 0, 0, 4, 0, then 0, 0, 5, 0, 0, 5. 0, 0, 5. So we can write the coordinate of other points. For example, B has been displaced along x-axis 3 units. From this x-axis, along this x-axis, it will be 3 units. So we'll have the coordinate as 3. Then along z-axis, because this parallel line OC is parallel to AB, so this one will be 4, then 0, like that. You can also have the coordinate of point E. The coordinate of point E, you can see that it is perpendicular, or we have this perpendicular line joining point E to B. So the coordinate of point E will be equal to the coordinate of B, that is on 2 dimensions, that is 3, 4. Then in terms of now 3 dimension, because E is above, E is going to be displaced now from the base, from the y-axis, with 5 units. So the coordinates of E will now be 3, 4, then 5, like that. 3, 4, then 5. So let's have a vector. For example, vector OE. So I join OE like that. Vector OE. Vector OE. I also have another vector. Let me join this vector OB like that. Then now I have this vector BE. Vector BE. Now I want us to see how we can find the magnitude of a vector in 3 dimensions. That is our interest. That's our interest. Now suppose I want to find the magnitude or the length of line OE. The length of line OE. So OE will be given by OB then plus BE. Now this one is the base. This one is the base. So this given vector here OE, maybe I can remove that triangle, so we have this triangle here. So this one is 90 degrees. So we have O, then we have B, then we have E. So you have this given vector. Now as you can see, it is a right angled triangle. So you have right angled triangle OBE. Now remember this line OB, it is lying on the plane, on 2 dimensions. That given plane, it is the diagonal or diagonal OB of this given plane OABC. So you have now right angled triangle OBE, and I have removed it here so that you can understand it better. So if I want to get OE, that is the length OE, I can apply the Pythagoras Theorem so that I have OE squared equals to the base, which is OB squared, then plus, this is OB squared plus BE squared plus BE squared plus BE squared. But look at OB. How do we get OB? OB is the diagonal. OB is the diagonal, and I can remove this given triangle OAB and have triangle OAB. So let me say this one is my triangle, this one is my O, then I have A, then I have B. So this again is still a right angled triangle. So this length OB squared, which is the diagonal again of this given plane. So this one is our hypotenuse. So we now have OB squared equals to OA squared, then plus AB squared plus AB squared. Yeah, OB is the same as OA squared plus AB squared plus AB squared. Now remember, AB is the same as what? OC is the same as OC. Is the same as OC. Then this OA, it is the same as BC or CB. So I can write it this way. I can substitute wherever I have OB. I can substitute it with. OA squared plus plus AB squared plus AB squared. So let's do that. So we have OA squared equals now to OB squared, which we are getting as OA squared plus now AB squared, then now plus BE squared plus BE squared. Now in our case, what is OA? OA is the displacement along x-axis, and we have seen from the origin to where we have point A is 3 units. We have in our case we are taking it to be 3 units, so we can have OE squared as 3 squared OA squared. Then we have AB. We have AB. AB is parallel to OC, meaning what? AB is displacement along y-axis, and we have seen along y-axis, point C is 4 units from the origin. It is 4 units from the origin. So AB squared is the same as OC squared, which is the same as 4 because C or point C or point B is 4 units from the origin along y-axis. So here I'm going to get plus 4 squared because AB is equals to OC because those lines are parallel. Then we have BE. BE is displacement along z-axis. BE is displacement along z-axis because BE is parallel to OG. Is parallel to OG. That means BE equals OG, and OG from the origin is 5 units. So we have here as 5 as squared. So now to get OE, which is the length OE, now we find that the square root of the 3 squared plus 4 squared plus 5 squared plus 5 squared. Now what does that mean? What does that mean? If you are given a general point, for example, point E, which is now you can take it as x, y, and z, where x is the displacement along x-axis, y displacement along y-axis, and E and z displacement along z-axis, or just maybe for clarity, we take a general point in terms of A, B, and C, where A displacement along x-axis, B displacement along y-axis, and D, here we have AB, and C displacement along z-axis. Then we can be able to calculate the magnitude directly, because we have seen that the length OE will now be given by displacement along x-axis squared, then plus displacement along y-axis, then plus displacement along z-axis, then you find the square root. So maybe for clarity I'm saying this: given a general point, let's say E with coordinates A, B, C, with coordinates A, B, and C, we can write these given points in terms of position vector, that is from the origin, as OE, like that, which as A, B, C as the column vector, where A is the displacement along x-axis, B the displacement along y-axis, and C displacement along z-axis. Then OE magnitude, we write magnitude like this: magnitude of the modulus will now be given by the square root of A squared plus B squared plus C squared plus C squared. And this is how we find the magnitude of a given vector in 3 dimensions. That's given a general point with point A, B, C, whereby you can express that point in terms of position vector. So we have OE as A, then we have B, C, then the modulus or the magnitude of that given vector will be given by now the square of the square root of displacement along x-axis squared plus displacement along y-axis squared, then plus the square of displacement along z-axis, Now to understand better, maybe we can have one example to sum up this. Now suppose we have been given a question like this. Find the modulus. Find the modulus of a vector, let's say maybe OA, which is equals to, let's take this one as 6, then we have we have 4, then we have, let's say, 5. Yeah, find the magnitude of that given vector. How do we go about this? So solution, we have seen that modulus will now be given by square root of x squared plus y squared plus z squared, whereby this x is the displacement along x-axis, displacement along y-axis, then z displacement along z-axis. So we'll now have our x in this case to be 6 squared, then plus 4 squared plus 5 squared. Yeah, like that. In this one, I will get the square root of that 6 plus 16 plus 25. Then you find the square root, and you can do your calculations to get the modulus. You can do the calculations to get the modulus. Now, I want to summarize by just to summarize this lesson by mentioning what we have learned. So we have learned that a vector is a quantity with both direction and magnitude, and we have also seen that given a vector, a vector in 3 dimensions, for example, let me say maybe vector A, which is let's say x, y, and z. This one can be written, or it can be expressed in terms of unit vectors as xi plus y j, then plus zk plus zk. Then we have also learned about modulus, or what we refer to as the magnitude of a vector in 3 dimensions. And I'll just start here. Given a vector, let's say given vector a, b, which is, let me just say a, b, c. This one can be expressed in terms of unit vectors. If this one, of course, is a unit position vector, it can be written as ai, then plus bj, not bj, but bj, then plus ck plus ck. Now the modulus of this a, b, we have seen it can be given by just finding the square root of a squared plus b squared plus c squared. We are going to end there. I want to believe you have learned something. Remember to subscribe, remember to share, stay tuned, stay safe until we meet in the next clip. Bye for now.